You are welcome to this section of the vector calculus class, and in this section we are going to treat yet another characteristics of vectors, and it's called the unit vector. Unit vector. A unit vector is a vector which has a magnitude of 1. The earlier videos were able to calculate the formula, derive the formula for calculating the magnitude of a vector. And for this kind of vector or vectors, the value or the magnitude is 1. And so we have the unit vectors have their unique place in the study of vectors. They help us define which vectors are parallel. See, when two vectors are parallel, or they are moving in the same direction or in the opposite direction, the unit vectors of each of them determines whether they are indeed in the same direction or opposite direction. And so if you have a unit vector, you can calculate of even have more vectors depending on the number you want to assign to them. So unit vectors play a very key role when you are studying vectors. It gives us the magnitude of a vector to be 1, and it shows that two or more vectors are parallel. And so if you take a vector A, which is a positional vector, that is positional vector or position vector, then vector with the heart, a heart, small heart on it, is determined as the unit vector. And so by definition, the unit vector A, for example, is defined as a vector divided by the magnitude of that vector. So that is how we calculate the unit vector of any vector. So let's take, for example, if vector A is the vector -1, -2, and 1, then if you want to find the unit vector, we need to first of all find the magnitude of the vector. So the magnitude of the vector will be given as the magnitude. We found it from the formula to be square root of the individual squared. So -1 squared plus -2 squared plus 1 all squared. And so if you do the arithmetic, -1 squared will give us 1, -2 squared will give us 4, then 1 squared is give us 1. So this one is going to give us square root of what? 6. Square root of 6. And so the vector A is unit vector A is given by the vector -1, -2, 1, all divided by root of 6. And then we can break them to each of the components, x-axis, y-axis, and z-axis. So we're going to have -1 over root of 6. This one will give us -2 over root of 6, and then 1 over root of 6. And this is the unit vector A. But from beginning, we said that the unit vector always has a magnitude of 1. So this is also included. So it means that if you find the magnitude of this unit vector, the answer we all expect to get is 1. Let's see whether it is 1. So you take the magnitude, and we know how to calculate the magnitude. You take the square root of the components. So -1 over root of 6 all squared plus -2 over root of 6 all squared plus 1 over root of 6 all squared. And so let's do a square root. -1 squared is 1. Then root of 6 all squared will give us the square root to go away, will give us 1 over 6. plus minus 2 squared will give us 4. And then root of 6 squared, the root will go away, we'll get 6. Then we have 1 squared is 1. The root of 6 squared will give us 6. So if you add the numerator and the denominator, the numerator will give us, they'll all have one denominator, which is 6. 6. So if you add 1 plus 4 plus 1, and I believe you're going to have square root of 6 over 6, which will translate into 1. So square root of 1 will give us 1. And so that will be this a genuine unit vector, because the value is 1. So we shall see how we can have or develop vectors using the unit vector. So if you take the vector A, and vector A, which is 1 minus negative 1, negative 2, negative 1, with its unit vector, which is this one, then what we can do is that we can have so many vectors modeled on this unit vector. So we can define another vector. Let's say find another vector, another vector B, which is, let's say, 3 times the vector A. If you want to find a vector which is 3 times the vector A, then what we can do is that we multiply vector B will be 3 times vector A, which is minus 1, minus 2, and 1. And that will give us vector minus 3, minus 6, and 3, and 3. This is a vector B which is 3 times bigger than vector A. But coming back to unit vectors, we can also create a vector C which has a magnitude of 2, but and which acts in the same direction as vector A. So this scenario is different from this scenario. Vector B is 3 times bigger than vector A. Now in the second scenario, we are asked to find a certain vector C which has a magnitude of 2, all right, but we are told that this vector acts in the same direction as vector A. And so we learned from unit vectors, that the definition of unit vectors, that if 2 vectors act in the same direction, then they share a common unit vector. The common unit vector. So with that in mind, it is easier to calculate vector C, since we know the direction of A and we know the unit vector of A. So in this case, our vector C is going to be defined as the magnitude of C times the unit vector of A, that is working the same direction of A. So the magnitude of vector C gave us 2, and then the unit vector of vector A is minus 1 over root of 6, minus 2 over root of 6, then 1 over root of 6. And as usual, the way we've written it, we can rationalize it. You can always rationalize it if that becomes very convenient. Then we can rationalize it. But for our purpose, we can leave it the way it is. So we can find vector C as what? Negative 2 over root of 6, negative 4 over root of 6, 2 over root of 6. So, and the last example that we can give on this unit vector is that we can have another vector, another example where we have vector D with magnitude of vector D equal to 5, but acts in the direction opposite vector A. You see, vector D is a new vector D. We have been given the magnitude, but we are told that that vector acts in the direction opposite vector A. Opposite means that they have different signs. So it's easier calculating vector D, which is the magnitude of D which has been given, times the unit vector of A. But since we are told it acts in the opposite direction of A, then the unit vector of A will multiply it by negative A, then the hat. So when we put the values, magnitude of vector D is 5, and then negative A. Negative A will give us, negative times negative will give us positive root of 6. Negative times negative will give us 2 over root of 6. And then negative times 1 will give us negative 1 over root of 6. And so if we put the values, if you open the bracket and put and multiply through, we're going to have 5 over root of 6, 2 over root of 6, and then minus 5, 10. This is 10 over root of 6, then minus 5 over root of 6. And that will give us the vector D. So, in a nutshell, or to wrap up, if we know unit vectors, you can create more and more vectors.